Hello, good afternoon. So this session that we are doing right now, it's going to be a continuation of what I did this morning. So we will work with the data access object design pattern that we have set up. And the purpose of that was a little bit different though. I showed you how you can use exception handling. It's just that for this session, we are going to use it for two different things. We are going to see how you can use generics so that you can have a single interface design, and then you can perhaps use it for different data types. Like you can use it for students, you can use it for course, for faculty, or any other data that you want to store in your database or in your file. You could do that. So that's one thing that we can do with generics. The other thing that we will see is how you can use this interface to have multiple implementations for the same thing. Like for a student, maybe you have the data stored in a file. That can be one option. Or maybe you have the data stored in a remote place like a database, a SQL database. So that having the interface is a very loose sort of coupling, which says that these are the methods that need implementation, but how you implement them can be quite different. So let me share my screen and get on with this. What I'm trying to show you here, let me write this down, that we have this student DAO, student data access object, which is an interface, right? So this interface has so far two methods, one that says FindAll, and the job of FindAll is to return you a list of students. Okay, so that's that. And then there is also another method. I hate that. Yeah, my journal crashed. I don't even know if I saved this thing before. No, that was for the previous class. So let me do this again one more time. And I don't even have my mouse cursor. Yeah, can see this. No. So we have this interface and the student DAO interface, which had two methods. Can't even see anything here, so I'll try. We had this find all, which was returning us a list of students. Okay, and then there was another method that says find by ID. Okay, this one was returning a single student if it exists, otherwise it doesn't return anything. Now, so these are the two methods that we got, and now I understand what it feels like to be a blind person. So this is sort of a DAO for student, but you'd soon understand that if you're working on a real sort of application that deals with students. Oh, my interface doesn't have an E. Okay. All right, let me try this out. Yeah. All right. Okay, so now it does have an E. So if you look at the student DAO, and you'd soon see that we'd also need stuff for course, because these students, they will definitely be registered for some courses. It's just that for a course DAO, we will have very similar kind of methods. We will need a method that says find all, and we'll also need a method that says find by ID, like find by course code. So essentially, this interface is also very much the same thing. It would have pretty much the same set of methods. Obviously, when we are dealing with student, then we are going to return a list of students, or a single student if you're finding that by ID. For a course, it's going to be a list of courses, or perhaps you're going to return a single course based on the course code. So to that respect, this is different. However, the core idea of these methods, they're going to be the same. Now, this would make us realize, like, why would you create separate interfaces for each and every one of them, right? If you can have a single interface where you can change the type, so instead of saying student, the FindAll that returns a list of student, if we have the control to say that FindAll would return a list of T, whatever that T may be, it can be student, it can be course, or it can be faculty, whatever it may be, then it saves us the trouble or the extra work of writing this separately. So that's one thing, okay? We're going to learn how to do it. So, although I'm talking about it first, but this is something I will show you a bit later. The thing that I want to start with is something else. See, if you have the implementation, well, the interface defined, what we can do, and we have done this before, is that we can have a student DAO file implementation. So basically, this is going to be a concrete class where we will have the implementation for FindAll. We'd have the implementation for Find by ID. It's just that in such a case, our implementation will be based on a file. It's not going to come from a database. Whereas we can also have the same methods, but we're going to read or write to from a database to and from. So we can have a student DAO SQL or MySQL implementation. Let me call it MySQL because that's what I wrote. Okay, so we can have an implementation like that. And so far we have handled all these things. We know exactly how to read from database. We know how to do that from file. So this is nothing really new. Let me show you a very quick example. We have this interface, student DAO. This is what I'm talking about. We have this find all, and we have this find by ID method, right? For a file implementation, which I showed you this morning, it is pretty much the same. It's not exactly the same because I made a stupid mistake. I forgot to commit this to our GitHub repository. So when I came upstairs, I was recording from my home last night and also this morning, but I'm in the same building, but I'm on a different floor. So what I wanted to do is I wanted to download the code that I did from my home, but unfortunately I forgot to do that. I forgot to upload the code or push the code. That's why I had to write the same thing again, because I didn't want to go back and do it. So it is pretty much the same, although there are a few differences, like I didn't do the exception handling. It meant I would have to write a few more lines of code, which I was too lazy to do. But essentially, it's the same thing, right? So if you look at the find all, it reads from a file. The file name is here, students.txt. It reads from there, creates all these student objects and puts them in an array list. And then we return that back. So that's essentially how this thing works. And for find by ID, it's pretty much the same thing as I did, that if the student list is null, then we call FindAll to make sure that all the students are populated. And then we run a loop through the entire thing and find that student by ID if that exists. Otherwise, we return null. Now, this is where we made that change and said that if a student doesn't exist, so in that case, we are going to throw some kind of exception so that the user or the caller knows exactly what happened. So that's that bit, okay? If you look at the test, we can do this very easily. I wrote 2 versions of it, which I'm going to go through real soon. So if you're going to read from a file, it does its job and it reads all the student records that are in there on that file. So we can see that we have read 7 students coming out of that file, and the file is somewhere here, students.txt. Yeah, this one. So yeah, 7 lines, 7 students, checks out. However, this is not the only implementation that we can do. What if we have a database where all the data is kept? So yeah, if I connect to the database, I have already created this. See, we got a student DB. I can say use student DB. And within that, if I have a look at all the tables available, show tables, there is a student table. If I say select star from student, I see that there are 2 records, one for John Doe, the other one for Jane Doe, right? So this is what it is. Now, if I want to write an implementation that connects to a MySQL database, like the one that I showed, if I write it in that way, instead of reading from a file, can we read from a database? Turns out it is really very easy. It's really very simple to do. What we need to do to read from a database instead of a file, we can create a new implementation. And that's what it says here, student DAO MySQL implementation. And it implements the same interface. So for student DAO, we may have an implementation that works for a file, or we may have an implementation that works for MySQL. Now, in such case, you see, in order to connect to a database, we need to get the connection. We did talk about it, right? Where we have to supply the server name, the database name, the username, and also the password. So once you get the connection, you have to create a statement, you have to write a query, and only after that you can execute that query, get the results back, get all the students' data from there, and return us the array list. So that's one way of working right in here. What I want you guys to realize, so we have written that. So the signature of the method, that doesn't change. It still has the same signature. It says FindAll. It returns you a list of student. Find by ID, we can write another query that pulls data from the database. So if we were to write select star from student, and we want a particular student, where student.id is equal to 4552, then it only returns the record of Jane Doe. What if I put a wrong ID? Then I get empty set. There is no such student with ID 4553. That's why it fails, right? So we know that we can write a simple query like that, and this is what I did. Select star from student, where ID is equal to the ID that you pass. And based on that, we can run the query. We get a result set where essentially you'd have 0 students, or you can have a single student, because this is going to be the primary key. You cannot have 2 students having the same ID. Now, if the student list has size greater than 0, I mean, we found at least 1 student, then we can return the student from the very first index. Otherwise, the student is not there, and only then we return null. So that's a very easy way of implementing these 2 methods. By the first one, we get all the students back, and by the second one, we get a single student back if such a student exists. If not, we will return null. So that's what we have written so far. Now, when it comes to using this or to test this out, what we are going to do is in student DAO, you'd see that this is so easy to do. If you're going to read from a file, you can say that we're going to use the file implementation. Or if you want to switch this around, you want to read from a MySQL database, all you need to do is to change this one line. So you can comment this out and you can uncomment this one. And when you run this, you'd see it reads from the database. Now, in order to set up the database, you know what dependency you need to add, and then you have to do a Maven refresh to get everything in there. but essentially what I wanted to show you that it actually works. So in terms of our coding effort, this is really very simple. We can change in one place. And in today's application development, this is a fundamental need. You can't just say that all my data, they're going to come from a database. See, if you're going to do it on a phone, right? A lot of these applications that you run on phone, you can be connected to the internet, or sometimes if you're traveling, you may lose the internet connection. So if your app needs to store data, if it needs to pull data from the internet, from some remote database, at some time, like this is just not going to be possible. So what it would then do is it's going to serve you data or store data locally on a file that is stored on your phone. And when it gets the connection back to the internet, then it can do the same thing. It can do a sort of synchronization, update everything with the database. So this is what I want you guys to understand, that your data source may change, but if you need to change the whole program just because your data source changed, then that is a very bad programming practice. And this is where interface really shines, because here you don't give the implementation, you only write the name of the methods, and the implementation comes from something else. So what's really happening here? We're using the same name. We are saying student DAO, right? That's the name of the type. That's an interface. But the implementation of it can be different. It can be a file implementation. It can be a database implementation. So these two things, they're different. However, they have a common name. And the name of the common thing is an interface. It's called student DAO. This is what is known as polymorphism. You have the method called FindAll. You have the method called find by ID. These two methods are there, but their implementation can be of different forms. So based on what we need in runtime, we can pick the implementation. So we can say either we use the file implementation or we use the SQL implementation, whatever be it, we can switch that based on our need. And that's why this is such a great advantage. You can write all these implementations if you have some common method names, and you can change the implementation there. It makes our programming or the entire design of it so very simple and so much adaptive to our needs. So that's what I understand by polymorphism. That's why it's a really important concept to master. It may be a little bit difficult to master to start with, but once you get the hang of it, you'd see that polymorphism is a really powerful tool. We are using inheritance, but yeah, the real idea is that we are able to override the definitions of these methods based on our need. It doesn't have to be all about interfaces. You can also do polymorphism on classes. So in the subclasses, when you change the name, the behavior of the methods, you're also applying polymorphism right there. So this is what I want you guys to understand. And this is the second part of the story. The first part where I said that based on your type, like be it student, be it course, or be it faculty, you can define the interfaces as you like. That's also very easy. I'm going to show you how to do it in the next part. I'll take a mini break. I got to make a few phone calls, and then we'll do the second part. So let me stop right here with this particular session, and then I'll add the other part along with the video, or post both the videos. It doesn't really make any difference.